first of all, what are we on here?
What we're sitting on here is a platform barge. This is the first one that we have ever built that can hold a algae harvester. And this is new emerging processes that we have developed that we're demonstrating now with the St. Johns River Water Management District here on Lake Jesup. And this is to really remove the excessive buildup of nitrogen and phosphorus from the water, extract it, and return clean processed water back.
Okay, so we're right here off the bridge on Lake Jesup. Explain how this thing works. So let's start from square one.
The first thing we do is we extract the water from the surface. So we're not looking at taking water from from the bottom. We take the phototrophic water zone, which is that first few inches where most of the sunlight is in the photosynthesis. We bring it through the system. The first thing we do is bring it into a mixing tank where we add organic chemicals to go ahead and coagulate the microscopic algae to bigger particles. So when you look at a water column, you'll see greenish water, but what we're doing is we're developing a process where we coagulate, bring the particles bigger, and then that is in tank one.
Okay, so you got the water coming from Lake Jesup. Follow the arrows, right?
Follow the arrows.
Going up here, and then it's going into here.
The tank one. So tank one is where we add our organic chemicals to coagulate the actual algae particles together. Okay. That essentially binds them together. In tank two, we go ahead and that's the flocculation process where the particles start to bind together. And then in tank three is where we put in pressurized water. And by putting in pressurized water, just like you have with a soda can, when you open it up, you'll see the oxygen coming out. We essentially take the lake water, we pressurize it in this tank, inject it on the bottom, and that creates nanobubbles, microscopic billions of bubbles on the bottom that essentially create a float blanket that raises the algae up to the top, essentially separates the water from the algae comes up to the top, and then from here, we skim it over into tank four. Okay. And then the water then gets returned out.
Okay, so at this point in tank three, you have a lot of muck right up here, and it's starting to separate out the better water down below.
Correct. What that does, as we inject this particular, we essentially take water, we put pressure on it, and by doing that, we take the oxygen in the water column and pressurize it, and then when we open it up, it releases microscopic nano-sized bubbles on the bottom. And that creates this white water effect, essentially a float blanket that allows the algae, carries the algae up to the top to this spot where we can then separate it from the water column.
Okay, all right, so that goes on to the next one.
On to the next one. So as you can kind of see, this is really a scalable system. This is not a complex system. This is a small unit for the barge for the research purposes, but this could be scaled to any size.
Now this is just research, so how much water do you do on a typical day when you're running this?
When we're running this thing, we'll run it at about 100 gallons per minute for 8 hours on a particular day. We'll get about 400 gallons of a bio slurry, which I'll show you that in a minute. But what we're really looking at doing here is seeing how effective it is in different parts of the lake. We're looking at different starches that we could use, because the other part of our research is to say, can we valorize the biomass? Because an algae cell has nitrogen, phosphorus, and carbon. And if we can take that carbon and transform it into fuel, we now have the ability to have a sustainable aviation fuel. And that's really what our work has been involved in the last several years. So while we have been able to prove that we can remove nitrogen and phosphorus from the water at a very rapid rate and take massive amounts of nutrients out of the water, we are now looking at the next step of saying, can we make this a closed loop system?
Okay, so just very quickly, so you have this lake here, massive Lake Jesup, right, that we've polluted over the years.
Right.
So we've gotten rid of the fish, the birds. Now what we've done out here can be converted into a fuel source, which we can use again, while also returning clean water. Is it in a nutshell?
Essentially it would be carbon neutral fuel.
Wow, okay. So a lake this size, obviously this is just the beginning of this process, right?
This is the gathered data for us to look and analyze on how we can scale this system up to address a body of water the size of Lake Jesup.
But in theory, if you're going to save a lake this size, you would need something a little bit bigger, right? If this works, that could be the idea. Is something
Absolutely.
a little bigger, and it can clean this up, bring life back to lakes like this.
Correct, and the way we have engineered these is to be mobile, that we can put these on land. Essentially, we can drop module units in, and we can scale these up and scale them down. So what we're looking for is that flexibility. We're not trying to design brick and mortar work where there's going to be a lot of engineering involved in cost. These are essentially a system that we can put in place essentially on a tractor trailer, park it, and then turn it on.
Wow.
It's that simple, and it's that effective, and we can do this with multiple trailers. So if we wanted to do something the size of Lake Jesup, we would use our mobile 1 million gallon a day unit, and we could stack those up, 10, 20, whatever, however many that we want to do. And I would envision for this lake, we would have them positioned around different areas of this lake.
One of the old fishermen told me this lake in areas used to be like 40 feet, 50 feet deep, and now in many areas it's 3, 4, maybe 10 feet deep. All right, so you skim off the nasty stuff on top. What about all the muck that's gathered up on the bottom? How do you eventually get rid of that? Does this address that?
No, this doesn't, but what this does do, any nutrients that come out of the sediment, what we call sediment flux, so if there's organic sediments in the bottom, they could put sediments into the water table, and if that's the case, then we would extract that. So while we're focusing on taking out algae, we're really taking out any suspended solids in the water. And by taking those out, we're taking out the nutrients, the unwanted amount, the excess amount. So this is another way for us to engineer a system with nature. So now we're giving tools to the water management districts, to the leaders to say, we now have another option on how we can implement and start mitigating our impacted waterways.
Okay, take us through the final step here and then we'll see some water.
All right, the final step. When you see the jar, the final step is this clear water coming out, and by us getting clarity to the water, so essentially you allow sunlight to penetrate, and by doing that, and as we run our systems, when we turn them on in the morning, within a few hours you'll see an abundance of fish hanging around here.
Really?
We're
that quick, you're
that
getting
quick.
life back.
Yes. So this is just showing that there are fish in the lake. They are attracted to the clean water. They will be coming out here. So this is really a wow factor when you look at it from the clarity of you'll see in the jars to what we're doing here. In a matter of a few minutes, we're discharging on a consistent basis clear, clarified water.
I know in your mind at night you probably dream about stuff like this, right? Clearing up an entire lake.
Absolutely.
How would that happen? Take us through it. I mean, would it take 100 years, 10 years with a machine big enough? What in your mind, when you dream about this, how does that work?
Well, and we have spent a lot of time thinking about that, and I've spent most of my life in Florida working on this particular issue, from the sediment issue now to the water quality issue. What we are looking at is having large-scale treatment plants that we would have on land. We would have mobile systems in the water so we can address a hot spot. In case an algae bloom starts to form in a particular cove, we can now get there rapidly and take that algae scum off. But our real focus is cleaning the water, taking nitrogen and phosphorus out of the water. The benefit that we're getting by doing that is we're also taking atmospheric carbon out, because the algae cell itself is taking carbon out of the atmosphere. And that's giving us the option now to transform that into fuel. By taking carbon and compressing it with heat and pressure, we're essentially taking geology from millions of years to a matter of minutes, and we can create biocrude. And that we really see as a game changer for the state of Florida. We know Florida has an abundance of sun, we have beautiful weather, but we also have an abundance of nutrients. So if we can look at taking these nutrients out and reusing them, then we have ourselves a plan, and then we can be the leader in the nation in biofuel and in clean water, and that's what our focus is.
Yeah, okay, it's a lot of science. People may not be able to fully understand the science. Bottom line though is, there are not many fish out here because of the way it is now, right? You can see them coming back. All of a sudden, an ecosystem springs back to life if the water's able to clean up.
Right, and the goal of these harvesters is really to give it a jump start, meaning that once we get the nutrient levels to a low enough level, the lake itself will go ahead and fix itself. It would go ahead and restore itself. You'll start seeing SAV growth. You'll start seeing habitats. And when that happens, then we can take our harvesters and valve them down and move on to the next body of water. So really what we're trying to do is take as much of that initial load out, drop it down enough to allow the lake the ability to go ahead and restore itself.
Okay, so let's take a look at the finished product. Take us through here.
Okay, so clearly, as you can see here, this is lake water that was taken out. This is the influent into our harvester. As you can tell, it has a greenish hue to it. Essentially, by us harvesting this water, this is the water that's coming in, we add the micro bubbles to the bottom that consolidates all this algae to the top. It clarifies the water to essentially this, and you can see the difference. In contrast, this allows sunlight to penetrate, and by doing that, we can allow the lake to get its SAV growth, its emerging aquatics, and essentially take this amount of nutrients and consolidate it into this area. And this biomass is nutrient rich. It has an abundance of nitrogen, phosphorus, and carbon.
What else could you use this for? You talked about fuel.
Okay, so one of the things that we're looking at, and we're working with the EPA now on a study on working with agricultural industries to essentially allow us to harvest or to teach the agricultural industry to use these harvesters so they can take their runoff and apply it back. Essentially reduce the amount of commercial fertilizer application and purchase, essentially creating another closed loop system. The other one that we're working on is taking this and transforming it into a feedstock for biofoams. Today, there's over 100 manufacturers from Nike, Adidas, et cetera, that are using algae in their shoes. Most of that algae is coming in from China. So we want to be able to allow us to provide U.S. algae in these markets.
Wait a second. You're telling me this right here can be converted into
shoes?
My shoes.
Correct. Right.
So airplane fuel, shoes,
yes,
feed, everything right there.
Correct.
Taken out of
right. We're looking at this as a product. So while we're taking it out, it's unwanted in the water, but now we have something valuable here that we can hopefully use and now create ourselves a closed loop, sustainable lifestyle that we can harvest the excess nutrients that are currently in our water and transfer them into something usable as a product to go ahead and reduce our carbon usage, to go ahead and create a green fuel and potentially fertilizer.
It's amazing science.
It really is, and it's a breakthrough, and our hats off really to the St. Johns River Water Management District for giving us an opportunity to come out this lake and to demonstrate this and to be our partners as we move forward with this amazing process.
And for you guys, it's a good business idea too. Not only does it clean up the lake, it gives you byproducts, lets nature come back here, people can start boating here again. There's so many byproducts to this science.
Right, and the other thing that really motivated our firm to lean into this is that harmful algal blooms are now becoming a widespread problem. They're lasting longer and are becoming more toxic. So we have to find a way to deal with that. Otherwise, we're going to lose our assets, we'll lose our water bodies. So we needed to develop something to mitigate that. But we can't just mitigate that, we have to do the whole circle. So while we can get the nutrients out of the water, we also want to create value at the end product.